Today we're going to be looking at an addition problem of x plus 1 over x minus 2 plus 3/4. So we have an interesting scenario here where we have this expression with variables and then we just have adding on 3/4. So here's what we want to do. First of all, we want to identify what values cannot be x, because we never want to zero out a denominator. So x cannot equal 2 because of this x minus 2 right there. So x minus 2 equals 0. We add 2, x equal to 2. Meaning x can't equal 2 because 2 minus 2 is 0. All right, so that's just one thing you want to make sure I identify what x cannot equal. Now we want to go ahead and just move on with solving this and trying to add these two expressions together. So we want to come up with the least common denominator. Least common denominator here is going to be x minus 2 and times 4. Just like if you had like the fraction 2/3 plus a fifth, something like that, you would identify the LCD as probably just 3 times 5 because you think about all the multiples of 3, 3, 6, 9, 12, 15, 5, 10, 15. So they both meet up at 15. So the LCD would be 15. So you'd have to multiply this by 5, multiply this by 3, and then you'd move on from there. We take that same concept and we apply them with these rational expressions. So my LCD is going to be 4 times x minus 2 because this term has a 4 and this term has a x minus 2. So they both need to be the exact same thing. So that means I'm going to multiply this by 4, and whatever I do to the bottom, I have to do to the top. I'm going to multiply this by x minus 2. Whatever I do to the bottom, I do to the top. And we want to make sure we don't actually multiply out the bottom. Just leave that alone for now. But we do want to go ahead and take care of the top. So I'm going to distribute, oops, click the marker or the eraser there. So I'm going to distribute the 4 into x plus 1. I'm going to distribute the 3 into x minus 2. And one thing you want to make sure you're noticing here, this is addition, so we don't have to worry about distributing any sort of negative. If this was minus 3 times x minus 2, you'd want to distribute that minus in there. But in this case, nothing to worry about. So we're going to have 4x plus 4 plus 3x minus 6 all over 4 times x minus 2. Couple like terms that we can combine. We can combine the 4x and the 3x. We can combine plus 4 minus 2. So 4x plus 3x is 7x. 4 minus 6, so 4 minus 6 is negative 2 over 4 times x minus 2. Okay. So now I think we're done. I'm going to say this, and if you might already know what I'm going to say. This, see that right there? No. Cannot just see, oh, I have an x minus 2 and an x minus 2. I'm going to cross that out because those are the exact same thing. Not actually what's happening. This is 7x minus 2. 7 times x minus 2. This is 4 times x minus 2. Whenever you're in this situation where you're like, well, do they cancel? Do they not cancel? These are not factors. 7x minus 2, this isn't 7 times x minus 2. It's not factors or multiples or anything like that. And think of it like this. Like if you were to plug in just x equal to 5. Like just think about it like that. X equal to 5. Would that end up sort of helping us out in understanding canceling? I always use this example also whenever I'm teaching this. If I had like 3 plus 5 over 5. If I asked you to do that problem, would you do this? Would you just cross out those 5s and say like, oh, I have a 5 over 5, that's going to cancel out, leave me with just 3? Like, no, you would do 3 plus 5 is 8, and then you'd have over 5, not going to divide, so you'd have 8/5. But the idea here is you can't just cancel out numbers or terms that look the same. Like you can't just see like, oh, I have a 7x minus 2 here, x minus 2 here. So the x minus 2s, I'm just going to create that, and that's going to cancel. No, not a thing. Can't do it. So the final answer here is going to be 7x minus 2 over 4 times x minus 2. There's no simplifying they can do. There's nothing that I could factor out. Nothing. So that's going to be it.